Here we are discussing a very interesting question from the chapter Relations and Functions. Question is basically based on the topic relations. Here question is, if R1 and R2 be two equivalence relation on set A, prove that R1 intersection R2 is also an equivalence relation on A. Solution is very interesting. So let us see the solution here. Here given that R1 and R2 are two equivalence relations on set A. It means R1 cross, it means R1 is a subset of A cross A as well as R2 is also a subset of A cross A. As we have seen in the definition of relations, that relation is a subset of Cartesian product of sets. Okay, so R1 is a subset of A cross A as well as R2 is a subset of A cross A. Here we have to show that R1 intersection R2 is also an equivalence relation. So how we can show that this relation is equivalence relation? We have to show that this relation R1 intersection R2 is equivalence if this is reflexive, this is symmetric and this is transitive. Then any relation is known as equivalence relation. Okay. Here as R1 belonging to A cross B, R1 belonging to A cross A, R1 is a subset of A cross A and R2 is also a subset of A cross A. It means this implies that R1 intersection R2 is a subset of A cross A. It means that is R1 intersection R2 is a relation on set A. This is clear that this is relation because R1 intersection R2 is subset of A cross A. So of course R1 intersection R2 is a relation on set A. Now we have to show that this is equivalence relation. So three criteria, three conditions we have to prove: reflexive, symmetric and transitive. First we'll start with reflexive. As given that R1 and R2 is equivalence relation, so these are reflexive. As R1 and R2 are equivalence relations on A, therefore ordered pair AA belongs to relation R1 and here also ordered pair AA belongs to R2 for all A belonging to the set A. So ordered pair A1, A2 belonging to R1 and R2 also, it means that is AA belongs to R1 intersection R2 also, because belonging in both the relations, both the sets, so will belong in intersection of these two sets also. It means this relation is reflexive. Therefore, relation R1 intersection R2 is reflexive relation. Correct? This part has been proved. Now let us see symmetric. Again, we will see that as R1 and R2 are equivalence relations, so R1 and R2 are symmetric. Here R1 and R2 are symmetric. It means if AB, ordered pair AB belongs to R1, this implies that BA also belongs to R1. Similarly, if AB belongs to R2, this implies that BA belongs to R2. So with the help of these two conditions, BA is belonging to relation R1 as well as in relation R2. So clearly BA will belong to intersection of these two sets, these two relations also. Now let us suppose that ordered pair AB belongs to R1 intersection R2. This implies that this ordered pair will belong to R1 as well as this ordered pair AB belongs to R2 also. And AB belongs to R1, it means BA belongs to R1. Therefore, BA belongs to relation R1, and similarly AB belongs to R2 is implying that BA belonging to R2. So AB belonging to R2 is implying BA belongs to R2, and this implies that BA is belonging to both the relations R1 and R2. So this will belong in intersection of these two relations R1 and R2. Therefore, BA belongs to R1 intersection R2. Okay, we have supposed here that AB is belonging to R1 R2, which is implying that BA is belonging to R1 R2. Therefore, R is symmetric. Therefore, R is symmetric. This second part has also been proved. Now third, we have to show that this relation R1 intersection R2 will be transitive also. Okay. So let us suppose that AB belongs to R1 intersection R2 and BC is belonging to R1 intersection R2. For showing that this relation R1 intersection R2 is transitive, we have to show that AC will belong to R1 intersection R2. Correct? As AB is belonging to R1 intersection R2, it means that is AB belongs to R1 and AB belongs to R2. Correct? That is AB belongs to R1 and AB belongs to R2. Similarly, in this case also BC belonging to R1 intersection R2. So BC belongs to R1 and BC belongs to R2. So BC belongs to R1 and BC belongs to R2. Correct? Now we'll make a group of these two statements together. AB belongs to R1, BC belongs to R1. So AB belongs to R1 and BC belongs to R1. Correct? Which implies, since R1 is equivalence, so this is transitive also. So AC belongs to R1. Therefore, AC belongs to R1. Similarly, AB belongs to R2 and BC belongs to R2. AB belongs to R2 and BC belongs to R2. This implies that R2 is also transitive because this is also equivalence. So here AB and BC belonging to R2 shows that AC belongs to R2. AC belongs to R2. Correct? Here AC belonging to R1 and AC belonging to R2 shows that AC belongs to R1 intersection R2. Therefore, AC belongs to R1 intersection R2. We have started from this statement. AB belonging to R1 intersection R2, BC belonging to R1 intersection R2. We are coming to this result AC belonging to R1 intersection R2. It means R1 R2 is transitive. Therefore, relation R1 intersection R2 is transitive. Okay, so here we are showing that this relation R1 intersection R2 is reflexive, this is symmetric, this is transitive. Therefore, this relation is equivalence relation. Therefore, R1 intersection R2 is an equivalence relation on A. So it has been proved. Okay, very simple, interesting. Question is very important. Okay, so hope you have understood it. Remain in touch with this channel, with these videos. We will discuss some more important questions, and hope you have subscribed this channel. If not, please get it subscribed. I need your cooperation, and share this video with your friends also. Wish you all the best.